Hello and welcome to this episode of our partner webinar series. I'm Buck Flannigan and I lead the partner efforts at Fluree on a global basis with people building their product and service delivery on top of Fluree's technology and going to market with us. We're really happy to have Prasad Yalamanchi from Lead Semantics as our special guest today. And Prasad will be diving into their product, which has been out in the market for a while, and some of the enhancements that they've done with the capabilities that Fluree's led in. So Prasad, welcome, and we're really excited to introduce you after this brief introduction to kind of level set where we are in the market, how the technology fits, and where we're really leading some innovation. So diving into the details here around the design principles that are behind Fluree, it's really trying to take this Venn diagram or this nexus where distributed ledger technologies with semantic knowledge graph, the standards, this is empowering developers and enterprises to deliver these next generation applications today. And it's built on this notion of a data-centric architecture. Fluree is most often compared against some enterprise blockchain protocols or traditional databases or triple stores. What being in the middle of this intersection is Fluree can be used as the backing data store for most modern applications and tailored to the specific requirements of vertical industries. And in this episode, Prasad will focus on AI-driven natural language processing to derive knowledge graphs, and then how to automate and operationalize, in this case, some contract agreements in a leasing rental scenario. What we've done here in some of the core of the Fluree data stack is to have these core principles that are enabled by our technology around the tenets of trust, so to have provable provenance and traceability of all the changes, and it's tied to a cryptographic signatures. This is some of the blockchain elements that we're bringing to market that provides tamper-proof data integrity via the block structure of the Fluree ledger. And then coupling this with W3C standards around the resource description framework and RDF, and other interoperability standards for both human consumption as well as making things instantly machine readable, and having these scalable knowledge graphs with semantic query interfaces to them. The data-centric smart functions that Fluree has, we enforce security directly at the data layer, which gives this single point of scalable information security, and it allows this notion of data defending itself. Another interesting aspect is this temporal dimension. So bringing together time as a first-class citizen, every piece of data within Fluree is time-stamped and traceable. And this allows a notion of time travel where every version of your database is immediately reproducible and cryptographically provable. So we need to obviously share and federate data where we can scale the query side and have this linear scalability of our graph database to get out to the edge and derive some in-memory types of speeds on the query side, giving you secure direct data access to third parties and make it multimodal. Not only Sparkle and GraphQL from the graph world, the Fluree query language, FlureeQL as a native JSON LD interface, as well as some recently released SQL and other standards. So where we've derived this and where our partners like Lead Semantics and others are finding that this is a great enabling path to the data-centric architecture, and most people that we have on the live audience today coming at this from a knowledge graph type of background are probably familiar with the data-centric manifesto, these key principles where we feel that the key asset of any organization moving forward in a modern economy is obviously the data, and being able to leverage data that can in and of itself not rely on siloed or this spaghetti codes of access that's come about with a traditional application-centric architecture. We love the open data standards and this notion of the semantic web. And this principle number 4 is where a lot of people come to Fluree, this data defending itself, where we've encapsulated the access rules with the data to be co-located and traveling along with it. So people that are writing these modern applications have a means to access the information stores and continue to share this in the data layer for this architecture. So having this notion of code as data, and this allows blockchain applications to fit into and scale in a data-centric architecture as well. Most legacy databases run the transactor engine, for the updates, with the query engine handling reads in a monolithic architecture. In order to provide scalability and of a modern database and the benefits of oftentimes a permissioned blockchain, Fluree implemented what is known as the CQRS, the design pattern, the command query responsibility segregation. It's a way to separate the database into 2 parts, with the Fluree DL as the persistent storage, our distributed ledger, and Fluree DB as the stateless query interface. This distributed ledger is the transaction engine, and it provides ACID guarantees one would expect from an enterprise operational data store. It essentially, it acts as a fully immutable historic audit trail representing every chronological state change to your database from block 0, from the Genesis block. So it's familiar to a change data capture like a CDC log, and it very efficiently captures deltas in what can be thought of as traditional CRUD operations in a database, and we can instantly reproduce any state down to the millisecond of the database at any point since that Genesis block in the database. The Fluree ledger can be privately deployed for internal use or distributed across a decentralized network. So you have the option of leveraging different consensus algorithms that have evolved in the DLT world. The most common deployment is a permission network running a raft consensus, making this pretty fast for updates to the ledger. Transactions that are submitted to Fluree are signed with the submitter's unique private key. So all of the identity and traceability, once they pass this layered security by the Fluree smart functions, they join the blockchain as that next immutable log entry. So this immutable ledger of data allows us to categorically prove time and source for every datum in the system. The folks on the live webcast here are probably intimately familiar with the SPO, the subject predicate object aspects of RDF. And Fluree even extends RDF, including information about time, allowing you to add and retract facts at a point in time, and having a extensible metadata structure for evolution of the standards around the RDF stack. Fluree DB is the semantic graph database that's optimized to make the best use of the Fluree ledger's RDF, these output of flakes. We all know graph databases allow developers to write sophisticated queries that can traverse the relationships, and because every update is immutably recorded, we can query against any historical point in time and retrieve that instantaneous response. And this is that time travel query feature. And FlurryDB, as I had mentioned, is multi-model, which allows you as a developer the choice of standard tools and technologies that you're already familiar with to make you efficient and effective right from the start here. We'll see some aspects of Flurry's smart functions as well. So smart functions trigger automatically on both the update path as well as the read path into Flurry, making it possible to embed security and permission logic within the system as data itself. This is that code as data. And these policies, because they're embedded within the data layer, they can leverage any conceivable set of conditions or linked data in the Flurry system as context for evaluation. So these smart functions simplify the enforcement of arbitrarily complex data logic and security policies, data shape validation, and this granular permissioning logic, relying on these linked data relationships. This gives you a lot of attribute-based access control in addition to the more traditional role-based access control. So within this framework, we open up our data sets to be queried directly by virtually anyone, and the data will be filtered or redacted according to the established rules associated with each user's identity. These smart functions can reliably evaluate user identity, user data, and because of Flurry's fundamental implementation of cryptographic signatures, we've got all of these queries and transactions in a consistent data-centric security format. People that are running our technology, you can run it anywhere. It runs on a simple and lightweight Java runtime environment and is often containerized via Docker and orchestrated via traditional Kubernetes clusters. So you can deploy this across on-premises, scale to bring your own cloud. You can run this on your laptop, AWS cluster, Google Cloud, Azure, any of these common environments that supports the JRE, the Java runtime environment. And we've even built our database in JavaScript as an in-memory and embeddable query engine to get data directly next to your frontline code. And we'll see a bit of this in the demonstration. So putting it all together, you can start working with Flurry on demand right away. We host and manage this for you, and you can provision your tenants and data sets onto an emerging and soon to be announced Flurry Open Data Hub. But we also run, as we said, on this bring your own cloud types of infrastructure, which Lead Semantics and some of our other partners have deployed very quickly to enhance their existing environment. There's also a lot of partners that have tools and other technologies that support your DataOps, your data science tool chain to deliver that whole DevSecOps type of life cycle. So we wanted to set some of this context with Flurry as an enabling technology, and it allows us to come in with our partners, going to market with our partners, and in this case, bringing Prasad on. Prasad's been working with Flurry. He's been in the community around the semantic web, the AI community and machine learning, specifically around natural language processing, unstructured text. So we felt it would be really good for Prasad to show what his team has done, talk a bit about TextDistil, some of their products and the visualization technologies that they have. So Prasad, I'm going to jump on mute for now, and I'll help drive your presentation along to your demo.
Thank you so much, Buck. Hi, everybody. First, let me welcome all the participants, wherever you're all joining the webinar today. I am Prasad Yalamanchi, founder CEO of Lead Semantics, as Buck had mentioned. Just about a minute about Lead Semantics. Lead Semantics is a semantic technology company, have been in this area for a few years, several years, I would say. And several of us have backgrounds in computer science and artificial intelligence and importantly, linguistics as well. And over the last few years, the way the technology landscape has evolved, it's not just the symbolic, you know, symbolic and semantic technology, but added to that, these neural and deep learning language models and so on have really elevated, the prospects for what we can do with natural language processing. And in that process, we have developed an end-to-end toolkit, which I'll have a chance to discuss it here and do a demo of some key elements of this entire pipeline. So with that, I will jump on to introducing the tool and then later on talk about the demo itself. So TextDistil is the name of the natural language processing pipeline that we develop and market. This is an end-to-end pipeline, and end-to-end in the sense that, on one end, you input text documents, plain text documents that are output of some creative work of people. And on the other end of the pipeline, you get completely queryable knowledge in the form of W3C standardized RDF enquads that can be loaded into any standard triple store, including Fluree, being that it is a W3C compliant triple store. So the pipeline itself, is built using linguistic rules, neural models and classifiers, and then ontologies, and in building up the ontology, there are taxonomies involved and so on. So all of these would play together in various parts of the pipeline, and then out comes these entities and relations, events, and all the things that you attribute to knowledge. And given that these documents are text and each document is independent of other documents and so on, we can run these documents in parallel. And so if we are running hundreds of thousands of documents, which is normal for a pipeline like this, so we would need a document management system, and we have a module to handle that, document search. And then our search is based on a semantic index. So you can actually search by the meaning of the document. So you can look for a subset of documents that fit a particular meaning and see what kind of knowledge it has and so on. But today the focus would be extracting knowledge and see how it fits into Fluree and the ledger aspect of it. In the demo, following a few slides here, we would input some plain text documents, pre-process them, extract the lexical and semantic structure, use them to feed into neural classifiers, and then extract entities, relations, and events, and so on. And then out comes these fact triples, which are enquads. Enquads are this W3C standard for semantic triples that can be loaded into RDF triple stores. And so we load them, ingest into these triple stores in Fluree, particularly in this demo. And TextDistil pipeline itself supports standard semantic querying like Sparkle 1.1. And then we also support query time reasoning. And then for triple stores that have full OWL support, we support that as well. So query time reasoning kind of does a lot of things for us. So that really helps in extracting derived knowledge as well. And part of the demo, besides the TextDistil, which is a server software, in other words, there is no real planned user interface for it. I mean, it is meant to run on its own overnight, several nights together on a cluster of machines and so on, without user interface, right? So any console output or logs are the only ones that are available. But to debug that pipeline, so we had come up with this tool called Fact Check, and it is an interactive visual graph that plugs into TextDistil, allows you to see the graph itself that is produced. So you can actually correlate the visual triples, the facts that have been generated out of this extraction back to the source text. And then, and that kind of, forms a loop where it allows you to see if all the configurations, all the linguistic rules, maybe the classifier thresholds, if you have to tweak them. And of course, that is a big part of the, before you productionize any of this pipeline software. So this really helps, and that's something that we will show you in the demo as well. So in this demo, what we will focus on is these contracts. Contracts are a classical, text documents that have plenty of text. It has a lot of rules, a lot of knowledge built in. And most importantly, these knowledge, so to speak, the facts that are embedded in this running text can be extracted, and they can be used to drive some constraints. The terms of the contract, the agreement between the parties can be, disambiguated, if you will, remove the discretion if you can, and, and the need for interpretation. And if you can do that, which is what TextDistil can do based on the ontology. And so once that extraction happens, we also can build the rules, the code that enforces these terms. And that is particularly the strength of, the features from Fluree. Fluree has this concept of smart functions. And so between the smart functions that Fluree has, being that it has this ledger at the heart of it, plus the TextDistil having its capability to understand language and then generate, in this case, it generates this code as well, besides the knowledge. And so together they get ingested into the Fluree database. And then at that point, Fluree database itself is available for a typical, web applications that can interact. Well, the code is fully armored, and you can't mess with the data anymore. And that reminds me what Buck had mentioned, is like data defending itself, with the code that is generated, that is wrapped around this. And so that is what we will show you along the way. So we will use a simple contract. And these contracts are called we are calling them smarter contracts. You may have heard about smart contracts elsewhere. But in contrast to that, this is smarter in the sense there is no human intervention in generating the code. And that, as I mentioned again, it is afforded by the core features within Fluree and then features within TextDistil. The smart contract itself is in a way self-executing. It's not executing totally per se, but at least it has the code to defend itself. And the code is generated automatically with the knowledge that is extracted. So that is the key. And then we also generate, the hash code for the entire agreement, the source clauses that have generated knowledge and the code, as well as the code itself. And the top level architecture is, the documents are loaded into TextDistil, and TextDistil produces the extracted knowledge as well as the smart functions. And then it kind of, gets implied on the Fluree ledger, ingested into Fluree ledger. Once that is done, then Fluree DB is available for querying or any application requests. And TextDistil also kind of, has this another output to fact check, which is the visual graph thing, which is what we will, showcase. So in the demo, what you will see is this TextDistil fact check interface, where on the left-hand side is the text pane, if you will, and to the right is the knowledge graph, that is the extracted knowledge in terms of facts, nodes, and edges with all the predicates. And then the ledger on the right-hand side. This knowledge graph is it will end up in the Fluree, ledger this way with all this information. So this is what you'll see in the demo. So I will move on to the demo right now. Before I move on to the demo, I would like to show you, let me share my screen, and I will share, Buck, I'm sharing my screen.
Yep, let me get you on. I think that's a great intro, great setup. I'll switch over to you, and you can take over the screen share now. There's a couple of questions from the live audience coming in. And I know that I would be remiss if I did not remind everyone to that's participating live, feel free to use the Zoom text Q&A, and we'll get to the live questions as much as we can in the time we have allotted. So Prasad, you are back on with your video, and feel free to dive into the demo here, and I'll go back and check out the questions.
All right, so I will stop my video and share my screen. Thanks. I hope you are seeing my screen.
We got it all the way from Hyderabad. We're
All
doing
right.
a
Yes, Prasad.
globally distributed webinar today.
Right. So we have our engineering center in Hyderabad. So I'm currently traveling here. So if you are seeing my screen, so I am just showcasing a simple contract. We have chosen a simple contract where the things that we discuss are pretty easy for folks to follow. And so that we are able to focus on the core aspect of it, the extraction part of it, and that ending up as data and its code that kind of, defends the data on the ledger. So these are typical contracts of apartment leases, and different apartment complexes in the US have different agreements, but the core things that they revolve around is the rent per month, and is there a due date for the month, the rental to be paid, is there a fine to be paid, few things like that, and these things are common across all of these types of agreements. And so what we have done is taken a couple of these documents, couple of these agreements, and then fed them through TextDistil and all the way into the pipeline. So I will, without waiting further, I'll just start on the demo. So I'll close this and I'll go to, I hope you are seeing my screen. It is the user interface to TextDistil. It's just a visualization interface. So I'm logging in.
Yeah, your screen's coming through great. Thanks, Prasad.
Yep. So you should be seeing the visualization screen here in a minute. It's loading. So this is a machine learning dashboarding and that type of user interface. We will go into the NLP side of it. So this is the NLP user interface for us. It's called fact check, and aptly enough, because the extracted data that we are interested in are the facts from the text documents that we load. So on the left hand side, you will see the area for the text that we load and run through TextDistil. And then on the right hand side is the graph, all the facts that are extracted through querying the Fluree database at the backend. So I will upload a couple of documents here. So we have few leases, something similar to what I just showed you. So we will bring up, so some simple document, one of the leases. It takes just a few seconds, it's a small enough document. So this is the document that's loaded. Yeah.
So this is all running in real time. Is that correct, Prasad?
Yes. It is running on AWS, our server cluster. And we are, now the data is processed and, the extracted, because we are only looking for some specific elements of the document, the rent, the due date, the fine per day, and, things like that. Few things that are driven by the ontology that we have set it up for. And these are all the predicates that we were looking for, or that we found in the document. And so we will bring them up. So clearly enough. So this is a little graph. Let's settle in terms of coming up. I will bring up the labels here. So this is, the facts that are extracted from the document, and in a second we'll see where they have been extracted from in the document. So this is just kind of space them out so you are able to read it. So.
And people can do big batch OCR on existing paper, as well as some of the native electronic items on this?
Yes, I mean, so ultimately, whether it is paper or electronic, it would have to be, in the electronic format, finally, for us. So if it's a paper document, we do an OCR and then, feed it through. If it's an image, we still do an OCR, and then as long as the text is able to be recognized by the software, then that's what we are looking for. And then, we are applying all the pipeline stuff to extract these things. And so here, I will click on, this is the the document, this is Greenwood's J something lease. So that is the document. And so this is a paragraph here that highlights the paragraph from which the facts are being extracted. So you can see that, so the rent amount is $1,000 here. So somewhere in here will be, yeah, I see 1,000 here. So the monthly rent due and all that is $1,000. And you can go by each one of these things, like, so what is the fine per day, is $10. And so somewhere in here landed may assess. So you can see the running language here is a lot different than the predicate for which it has qualified itself to be a fact, so, but ultimately, we are getting what we need, so that's the key. So the fine here is that, and rent is here, and then the lease itself has a term, and we'll see if there are dates here. So there is a December 31st, which says lease end date is December 31st. So somewhere in here, we'll see, yeah, December 31st shall run through December 31st. It starts on January 1st. So there is a lease start date. That must be a lease start date here somewhere. Move it up. Okay. So lease start date is January 31st. And then shall run through December 31st. So, those are the start date, end date, rent, and the fine. And rent due date is first day of each month. And so rent due date is, I see something here, shall be $1,000 payable in advance on the first day of each and every month of the lease term. So you can see that got picked up. So these are the different, things that we were interested in. Of course, the document itself runs through much further. We can pick up anything that we wanted, assuming, we seeded the ontology and the linguistic rules, should they be necessary, and the classifier, should they be necessary to be tweaked, and so on. But here we wanted to kind of, pick out one specific use case of being able to pay rent. And then there are some penalty clauses here, clearly if the fine is, if the rent is not paid by the due date, there is a fine. And so we want to see how the ledger now defends itself, how the code that we generate, by now, the code is already generated and it is in the Fluree database. Now we'll see another interface that just connects to Fluree database, and we'll get to engage this, payment of the rent and the fine calculations if it's all being, properly handled. So I will reset here. We can load, multiple documents even. I'm just kind of, so I have 5. We can load all the 5.
Yeah, for this demonstration purposes, we're on the order of 5s, that type of stuff, but 55, 1,005, 100,005, this is meant to be scalable and big batches, as well as some of the more high value needles in the haystack that you're looking to automate here.
Yes. So clearly the user interface will not run with millions of documents. Clearly, even 5 documents will produce quite a bit of a clutter. And clearly here the ontology is a lot more limited. What we are looking for, the predicates that we are looking for. In a batch mode, when it runs, fact check is not connected to it. This is a debug session, that we can connect to a live TextDistil and all that. TextDistil parallelly can run as many processes as your computing cluster can, afford. Because each document is independent of itself, and our algorithms run, for each session separately. And so literally it can scale up to any number. Hundreds of thousands is not a problem. Millions should not be a problem. Again, computing would be the only gating factor there. So this is
there's a couple of questions that had come up, Prasad. I just kind of wanted to jump in. This demo started, I've gotten a cascade of a bunch of live Q&A. Do you mind if I ask you just about ontology? Because 3 or 4 of these live questions, I think you can probably hit now and then move to the next phase of the demo.
Sure. So you have a certain question. I'm sorry, I'm not keeping up with the Q&A.
Oh yeah, I can read it to you. Kyle had a question. I'll try to aggregate all the ones that came in, but Kyle's question said, sounds like you have an ontology. How was the ontology generated? And then Abhilash had a similar question. How is the ontology defined for the data? is it the available ontology or defined for the data? And Marco as well said, what is the ontology that is used to associate for word sense, disambiguation? Can you feed it your own? So I know that was a lot, but I kind of grouped from 3 different folks around the world with us live. Do you want to just spend a minute or two talking about that?
Yes, I mean, I will mention in passing here, and then towards the end, we will probably get into it more deeper. Is that okay?
Perfect.
Yeah, so the ontology here, is already shown here in terms of the predicates. For example, the tenant address, the title, these are all the elements of the ontology. Because we are not doing an open-ended extraction. We are strictly, because it's a commercial enterprise, commercial application. So we would have to fit into exact, the predicates and the entities that will be used by a downstream application just by querying. And so the downstream application will have to know what it is looking for in terms of, preparing those queries. So in that sense, we are not doing an open-ended extraction. So it is guided by a strict ontology and limited in that because we are only focused on the fine, the rent per month, and, the due dates and, the few things, maybe, 10 such elements here. But it forms a nice group of things that are revolving around a prospect for generating very strict, code, data defending code, and so that's what we were looking for, so that it is illustrative in a webinar like this. Great. Can I move on here and then, get on to that a little more in depth later on? I know there was some aspects of the questions here that were asking about, so the elements of ontology and, how it fits into. So, I mean, I can get into that a little later.
I think that's great. That's also a good next step. There's some other specific questions about medical domains and documents and some other things, and we can always handle those after the time box for this webinar. So yes, please go ahead, Prasad.
Okay. So I would want to kind of show you, what is the data that is being loaded into Fluree, and then, what type of application interface would that support, given the knowledge that we have extracted. We have, kind of, went over what it is that we are extracting here. So I'll quickly switch over to this other application that we have created. It's a simple user interface application that will allow us to query the Fluree, ledger at the back end. So I am connecting to the Fluree. So this is the simple user interface. It's just a little scrape, pretty much. I mean, all it does is, connect to the ledger and then see what contracts it has. We have done, as we have seen, we have 5 documents that we loaded here. And it is now this application is reading those 5 documents, and it has extracted, the different information that was extracted from the actual text itself. So it has the tenant names, the full name, the start month, end year month, landlord, and rent per month, rent due day, and the fine for each late day, and then the hashes for the document, the clause, and the smart function itself. So this is, and then we can further go on to see, like, for example, we can do, any one of these things, like check to see it is a rent per month is 1,200, rent due day is the 3rd day, and fine if the rent was not paid on the 3rd, it is 15. And so if so here are the, so it has generated all these pending invoices, so to speak, so invoice is not paid because it's all false. All of them are false. And it is starting on the month 3, all the way to, or, month 8.
So this demo prototype here, just to clarify, Prasad, so you're showing it's actually some operational data coming out of this automation where it's not only the knowledge graph, but now you're into the operational data store and showing what you can do end to end for this?
Absolutely. So we started out with the text documents here, right? On the left-hand side, if you see my screen. And then we extracted the knowledge. This is just for our, understanding purposes that we are viewing the knowledge graph that is generated. And then we are saying, okay, now the generated knowledge and the associated code that was generated is already ingested into the backend Fluree ledger. And now this is a simple user interface connecting to the Fluree ledger, operational ledger, and then seeing, what contracts are there. And so these are the 5 that we just, processed through TextDistil. And then this particular interface here is completely engaging the data defending code that has been generated on the fly. So here, these invoices are pending and not paid. So we are saying this gentleman he has to pay $1,200, and I'll put 1,200 here. And the paid date, it is due on the 3rd of the month. And if it is paid on the 3rd, it should be, that should be fine. We are not connected to the wall clock because otherwise it would not let me, do these multiple things, because wall clock is set on wall clock's time and not on, we cannot mimic the months that we want to show here. So we kind of disengage the wall clock and we just put the, days, months, and, months and years.
Sure.
So if I paid the exact money, so it should allow. So of course, it has allowed, but it has turned, the ledger has turned itself as true for this record. So I'll go on to the next one. So here, the gentleman were a little bit lazy and didn't pay on time. And maybe he was trying to pay the same amount on 1,200, but he's trying to pay on the 5th or 6th, whatever. Right, it's clearly later than the due date, and so normally the data defending code should not allow 1,200. It would expect the additional fine as well, and clearly it fails. Please check the entered amount. So we put a simple response here, and if the amount entered should be, it is 3, so it should be 1,245 because it's 15 times 3. So we will see if it will allow that. Of course, it allows that. So as you can see, the code that is generated and instrumented within the ledger is operational and active. So
it looks like your developers are using the React plugin, where I'd mentioned, scaling it out with the JavaScript and some of the other UI frameworks, and it's a pretty snappy update. So it looks like for this demo, you guys plugged into the React libraries with Fluree.
No, we are using Node.js library and of Fluree.
Okay.
Yeah. So we didn't want to put too much effort on the user interface. Clearly, this is just reading and writing on the screen. That's it.
Yeah, well, I think it shows, just the interactivity with the backends and where people can plug this into human-based operators, or as you scale out, some of that data can go through robotic process audit, all the RPA stuff, and interact with any enterprise's existing payable system. That's really cool.
Right. I mean, so the APIs are clearly there, and you, as an application developer, are clearly, if it were an apartment complex, they would not have to worry about, how do we operate? I mean, of course, it sounds simple, but, there is no human intervention, as you can see. It's all generated automatically. So that makes it for very simple app development on the other end to kind of, manage these kinds of contracts.
Well, that's fantastic. We've got in the time allotted here some potentially deeper dive questions. Prasad, how would you like to wrap things up?
Yeah, I mean, I would like to stop the demo, assuming the end-to-end picture is given. Now I can definitely look into the questions, depending on the time. Yeah.
Sure.
Okay? Yeah. All right. So can I look at the questions, and how do I go about?
I can actually probably read them to you. That might be the easiest here for this particular episode, if that works for you, Prasad.
Yeah, I think that would be great. So thank you for that. Yeah.
And thank you for that that demo. That was really cool on the end-to-end items.
Sure.
So let's do some of the live questions. I want to make sure things didn't scroll off from the top, so I'll try to take them from first in. Pierre had a question about how are the data usage rights handled?
Okay.
I'm not sure what that one exactly was, but
Buck, I think that came in when you were talking about the Fluree system earlier on.
oh, okay. Yeah, I think that goes probably more into smart functions, and in terms of data usage rights, that's typically done via an identity type of system, and the digital signatures involved in users and how the permissions are defined at the Fluree smart function data layer. So that's actually another webcast, Kevin, that I think we talked about data-centric security, that we'd encourage Pierre to either ping us on Slack and we can go through some of that in detail on Fluree.
Yeah.
Sounds good.
Marco is asking about the cost to use TextDistil, and you don't need to go into any particular details here, Prasad. I don't want to put you on the spot for a price quote, but it's always good when people are just asking in general about your commercial model.
So we at least one model that seems to have worked is that we make a TextDistil server with a particular configuration, so it has a built-in capacity of sorts. Because clearly there is a cluster of classifiers at the back end, and so there is cost involved in the computing itself. And then there is a cost to the license. These are the two components, and we can talk in detail based on what Marco is looking for.
Great. Ioannis, I probably just massacred that name. I apologize. But the aspect around English language was here, and I know different character sets, and obviously the way you train your machine learning framework around NLP is very, very tied to character sets and obviously semantics and grammatical aspects of languages.
Yeah.
Is there anything in your roadmap for, are we doing English only here for now and maybe looking at other languages in the future?
We are at this point, I think the clear thing is we are focused on English right now. And there is plenty of things still to do in English itself, even though we are covering a lot of ground. But we are interested in getting into other languages. There is interest in Spanish. There are folks that are asked for Spanish. And then there is an interest in German as well. But I don't know that we are ready to handle that at this point.
Sure. Marco was asking again, is the pipeline customizable? Let's say I wanted to qualify the facts for higher accuracy.
Yes, it is very customizable, but although, because because as I said, there are linguistic rules. The linguistic rules will cover, what types of clauses, what types of phrases, what is a verb, what is an event, how does the verb play into an event? There are various such rules that are there. So once it needs a bit of training, bit of understanding rather, bits of playing around before you get to kind of, routinely modify it when you see something wrong, a wrong fact in the fact check user interface, to go back and fix it. You would have already spent some time, maybe about a week or so, playing with the entire configurations. There are plenty of configurations. And then, as I mentioned, there are classifiers in the middle. So we kind of move the data through the symbolic side of it, the language rules, and then we kind of, project onto these classifiers and classifiers thresholds, and we do an ensemble on top of these classifiers, because any given one single model we cannot rely on that. And even an ensemble many times will not, give you the right answer. And so we again have linguistic rule configurations on top of the output of the classifiers. And then we have rules that kind of guide them to the ontology that we are specifically looking for. So there is a beam search and a beam reception, so to speak. of all these elements that are moving through the pipeline. So there is plenty of configuration, but there is a science to that, So a little bit of, spending time with it.
Sure. That's great. Raja Babu was asking, is it possible to capture scanned invoice and to integrate with SAP?
So if I understand the problem there, I mean, invoice, the data encoded in the invoice can be extracted. That is, it doesn't elevate to a level of complexity that a proper knowledge extraction that TextDistil can do. But that said, there are modules within TextDistil that can easily handle the extraction of invoices. And then once extracted, we can route it to any downstream system, in any of the formats like XML or JSON or strict SQL dumps and things like that.
Yeah, and I think that's where TextDistil and the Lead Semantic products powered by Fluree and the federation and some of the data integration you get naturally with these Fluree powered systems. It's a real nice fit together.
Absolutely. And just to, if there is a minute, I mean, I know there was a question related to ontologies early on, which I did not touch upon and wanted to kind of touch upon a little later. So the ontologies they play a fantastic role in kind of, grooming the outputs that come out of these statistical models, and linguistic rules, no matter how much we kind of, put them together, we cannot be exhaustive and definitely not comprehensive to fit the actual text that you're processing. And so the ontology on the other side is the receptive, if you will, is the receptacle with definite filters that will guide you to where this data needs to go. And in that sense, all the disambiguation, at least it gives you a chance to, instrument these rules appropriate to the disambiguation that is necessary, that will work for the specific application. In that sense, we have been very effective in getting exactly the facts that are required for a running downstream application. And so all these elements have to kind of, fit hand in glove, and configurations have to be tweaked, of course.
Oh, that's great. Yeah. A couple more and they're still coming in. So as long as you've got a little bit more time, Prasad, we can check a couple more.
Sure, absolutely.
Petrus was saying, hi, great presentation. Thanks, Prasad. My question is, who is the product for? Which industry would mostly benefit from the use of this product?
So I would say the financial domain, for example, the contracts is one area. There is a lot of text, is pure text on one side. There is a lot of embedded, knowledge, so to speak, clear data elements that require to be defended through, this kind of automated code generation. Of course, during the development phase, you would put it through rigorous testing and, all of that. But once done, you have, first 100 contracts, you go through, all the testing and, all of that. And then you have, 100,000 contracts following that. So there is no need for human intervention. That is the goal, so that is one area. Mm-hmm. Financial documents, like, any financial document has enough of information. Business news has enough information, that can be used to, all the, knowledge is always changing. That's what, everyone is aware of. So even though we may have a snapshot of a knowledge graph, but the elements in there are definitely changing. Our properties, our associated elements are changing. And so that needs to be one way or another fed back into the knowledge graph. And typically this knowledge kind of manifests in text somewhere, and then so that becomes a key. So financial domain, healthcare is a big area, and then supply chain is another big area. So these are big areas where random outside text has information that is relevant for, whatever the application that you may be looking at in some ways.
I think that's great. And Raja Babu had one other follow-up question. And I think you touched on some of it in those horizontal supply chain types of use cases, financial, those can cross-cut across specific industries. Raja Babu is asking about use cases in HR.
Yeah, I mean, so HR, I would say there's a lot of descriptive elements in terms of, wherever text kind of, encodes a lot of crucial information that has not made it into your transactional databases yet. like, all resumes are a lot of text. Other than picking these keywords and all of that, there is a lot of qualitative information that is still kind of left over within the text. And so all of that can be, nicely brought into a structured world, and then, make it available to your normal querying systems. And that really enriches and, it expands the prospects for new information to kind of now participate in your decision making.
Great. There's a couple more and they keep coming in, and Kyle had been asking about, is it possible to use a custom ontology? And someone else, he noted somebody else had asked this earlier. So one final answer, and then we can obviously have all the next steps, but can you talk about just the tailoring or customization of ontologies?
Oh, absolutely. So every domain, every application that we run with, so we work with, business news kind of feeds. So there is a separate ontology because the need for specific elements of it is expected in the downstream automated applications. So there is that imposition, because in that sense, we are elevating, totally unstructured text into your structured transactional world without human intervention when it is in production. And in order to do that, the downstream expectation will imply itself in terms of an ontology. And so there is an ontology. So, we will always have an ontology, and it is easy to generate, and it is customizable. How deep an ontology depends on, what is your, how far are you looking out into the future. Typically from text, these surface forms that kind of, manifest in text are already complicated enough before you can, link it to the knowledge base that you may have. Like Bill Gates is the Bill Gates that you know of, right? With all the different things that so the surface forms to connect back to the actual knowledge that you have, that itself is a big challenge. But then if you want to add all the other aspects of real deep ontology, then that is what you need to make a decision on. Like, Bill Gates is a person and it's a humanitarian and, all those other aspects. If you feel like, you are kind of have a prospect for applications in those areas as well. But, given RDF and all that, it is extremely scalable and you don't have to make those decisions upfront. Your ontology can scale as well, along with the data that you see newly.
Fantastic. Questions keep coming in. As long as Kevin Doubleday says we can stay live, I want to give it as much as we can, as long as you're good with it, Prasad.
Oh, I'm good for it. Sure, no problem.
All right. If you want to you can turn your camera on if they want to see your smiling face on this, if you wish, Prasad.
So as I said, I'm speaking from India, and so it's already a little late in the night. So
North Carolina to India and everywhere in between. Fluree and Lead Semantics have kind of a global footprint here, and it looks like we've got people from all over the world with these live questions. Back on the smarter contracts, kind of the operationalizing it looks like Marco is asking, in the smarter contracts page of the demo, the payment section included areas to be filled. For example, payment amount, date, and pay amount. Were these automatically generated by the detection of the terms in the contract?
Right. So by aligning the ontology, so the predicates that were there in the picture, in the slide, were part of the ontology. And so we were looking for, by meaning, what it is in the contract that suits it. And that's why we are able to move from one type of contract, from one apartment complex to another apartment complex, without having to redo the ontology. Does that make sense?
It does.
Yeah.
And
so in that sense, it's not just, so typically if you're only looking at, one apartment complex or something, information extraction, which is like, very hard-coded style, might work. And, but with an ontology and, all this pipeline stuff, what it is you are able to abstract it to a level where now you are negotiating meaning between what the ontology expects and what it is written in the text, in the contract itself. And in an apartment complex, there is a fine, one way or another, whatever they call it, as long as it is English and is legally, reasonable. And then there is a rent and there is due date and there is, all those things. So that's where the power of this pipeline comes in.
okay. Great. There's another question, and this is getting into some specifics. In the Zoom interface, Prasad, I'm going to put your information in there just as the lead partner for Fluree on all this. So hopefully you're okay with that. You're becoming quite popular in our community, and this is quite exciting. There's two more quick questions from Marta. I was asking, how well would this system work with medical/clinical text?
It should work very well, as long as the taxonomies are there. We have played with, medical text, biomedical domain. So the taxonomies are what will guide us to create the ontology that you're looking to extract from the documents that you're looking for. So in medical domain, gosh, I mean, the ontologies are already there. There are taxonomies that are well documented, standardized, and so on. So, and I would say there is no problem at all. Financial domain, medical domain, because of the standardization that has kind of, crept in all the way into terms and the language used and so on. And clearly, I mean, there are esoteric pieces like, we will run into that, but that's an iterative process in the beginning, but it is definitely game.
Great. How about this one? We have over 6,000 scientific articles. Each has 20 plus classifiers with an existing ontology. How can Lead Semantics help to get to Fluree?
Okay, so 6,000 we can set aside. Each article, if you look at it, there are 20 classifiers, all kind of, leading up to certain labeled entities with an existing ontology. I would say, I mean, it is fairly reasonable, so we just have to take a look at it. We can do it. Is there a chance to get what domain it is?
I can't tell from this particular person's ID, but
you mentioned scientific, but is it biomedical or is it anything else? Like physics?
Yeah, it looks like it could be a PhD. Oh, look, I love the Zoom real-time stuff. The domain is pharmaceutical. Okay,
so it kind of, medical healthcare domain. Again, terminologies, as long as they are there, available taxonomies, and then, a representative ontology, if it is there, and clearly they have, the person has mentioned, there is an ontology and there are classifiers already decided for it. So we can plug them in, we can use them in the pipeline to see, how it works.
That is really, really fantastic. We're past the top of the hour here for the live broadcast. The nice thing is this has all been recorded, and we will have this as an evergreen asset, at least for some amount of time. So Prasad, I wanted to thank you very much. You and your team put a lot of work into doing the demonstration and showing it end to end. This is opening up some new ground in the knowledge graph domain and kind of extending things beyond the value proposition of triple stores, leveraging what Fluree can do in terms of distributed ledger, the traceability, and the trust aspects, as well as going towards more of that end-to-end operational data store. Partners like Lead Semantics that are using us for enabling technology. This is our key path into the market. So I wanted to thank you once again, wrap things up here for the live broadcast, and we'll look forward on fluree.ee/try, leadsemantics.com. Everyone keep the questions coming, and we appreciate all the innovation. Prasad, would you like to wrap up?
Yeah, thank you so much, Buck, and thank you all for the participants for wonderful questions. And this is a great area. Text is the new big thing, and there is so much knowledge and text are two sides of the same coin. That's our passion. And so we think, that it opens up new grounds in terms of, where all it can lead to, because knowledge is the next area for AI itself. And I think, it's becoming front and center, and we are there, excited to kind of, participate in that. Folks that are interested in reaching out to us, we are on leadsemantics.com. There is a contact us page. And of course, you can reach out to Fluree and Buck and Kevin as well.
Wonderful. Thank you. Cheers. That's a wrap for now. See you guys soon.